Today we are going to discuss the analysis of algorithm. Analysis of algorithm, two things we can analyze. So one is the algorithmic complexity, second the problem complexity. That means how much complicated the problem was. So two complexities we can able to analyze. One is the complexity of the problem, where we need to solve the problem in terms of algorithm and program, and the second one is the algorithm complexity. So upper bound is used to find the algorithmic complexity and the lower bound is used to find the problem complexity. Upper bound of the algorithm is shown by the asymmetric notation called a big O notation. So if you find the complexity of algorithm, usually we denote as a big O notation, so capital O, cap O. And if we are interested in finding the lower bound complexity, then it is denoted as a big omega or just a omega notation. Now we are interested in calculating the complexity of the algorithm. So the complexity of algorithm have two types, two complexities we can able to find. So the first complexity is the space complexity, and the second is the time complexity. And in these two complexities, usually we are very much concerned about the time complexity, because all the systems, or we need the result to get as soon as possible. So usually we are interested in finding the time complexity. So both the space and time complexity are denoted in order of big O notation. In big O notation, again we have several types of big O notation based on the complexity of the algorithm. The first one is order of 1. This is called as a constant complexity. The second one is order of n. It is called linear complexity. And the third one is order of n square. It is called quadratic. And the fourth one, we have order of 2 power n. This is exponential. And the fifth one, we have order of log n. This is logarithmic. So these are the 5 types of complexity we have. Let me adjust the size. So now let me explain one by one. The first type, order of 1, constant. So in this constant, the algorithm's time complexity always the same, irrespective of the input data size, input data set or input data size. For example, I can say we have some integer main. I have one program, integer main, cout, welcome to the channel. Welcome to the channel. So whenever I run this code, this always executes in the same time. So it is mentioned as a order of 1. It is a constant time complexity. and the second one is order of n, linear. In linear time complexity, the algorithms time complexity grows linearly and directly proportional to the size of input data. Example, I can say the example of this one is int main. For I equal to 0, I is less than or equal to n, I plus plus. Some code under the for block or a for loop. So this one, the complexity of the algorithm always lies based on the value of n. When the n value increases, the number of iteration of the loop also increases. So that's why it is the order of n complexity. And then number 3, the third one is order of n square quadratic. The algorithm's time complexity grows rapidly and directly proportional to the square of the input size. So here I can give the example of int main. I use the just little for I equal to 0, I is less than or equal to n, I plus plus. For j equals 0, j is less than or equal to n, j plus plus. Some code under the j, second for loop, that is all. This one already we know the for loop has the complexity of order of n, and this one again the order of n. That means the inner for loop will always run the number of n time. So it will run, if you combine the both, so we'll have the complexity of n square. In general, we can say that if the code, in general we can say that for two nested for loop or for two nested any loop, not necessary to be a for, two nested loop, the complexity is order of n square, and for three nested loop, the complexity is order of n cube, and for four nested loop, the complexity meaning that time complexity is order of n power 4. In general, for m nested loop, the complexity is order of n power m in general. Right? Very easy. And the last one, the fifth type is not, actually we are in the fourth one, already three completed. Now the fourth one is order of 2 power n. The algorithm time complexity, grows double with each addition of the input data set. For example, if I take the Fibonacci method, I'm passing the number n. If n is less than or equal to 1, then return n. This is just a simple Fibonacci series calculation. Return n. Otherwise, return fib, calling the same function again. It is a recursive function, -2 plus Fibonacci series, I mean the method name fib of n minus 1. So this Fibonacci method, the complexity is 2 power n. So in general we can say any recursive 90% of recursive 90% of a recursive algorithm will have the complexity of 2 power n. And finally the last type, the fifth type, is order of log n. The algorithm's time complexity grows very slowly when the size of the data increases. For example, we can say int main for I equal to 0, I is less than or equal to n, I equals I times 2, some code under the for loop. So this kind of algorithm takes log of n. Another example for this complexity, log n complexity, is binary search or binary search tree, and many tree traversal, tree data structure has the complexity of order of log n. Okay guys, understand? See you, bye bye, have a great day.